Hey there again, pre-calc students. This is Mrs. Y speaking. Today we're actually going to combine two different lessons. We're going to combine our 4.4 lesson, which is about the rational root theorem, and we're going to combine that with 4.5, which is locating zero. Now, some of the terms to know, you probably want to jot this down that you might hear again or they might sound a little bit familiar, is the rational root theorem, Descartes' rule of signs, the location principle, the upper bound theorem, and the upper and lower bounds. Now we want to take a look at the rational root theorem. It states that if P over Q is a root of the equation, then P is a factor of the constant term and Q is a factor of the leading coefficient. Now we've talked a little bit about the constant term and leading coefficients in our first lesson when we discussed polynomials. So this might be just a little bit of a recap and taking a little twist on it. Now an example that you might see would state, list the possible roots of 6x cubed plus 11x squared minus 3x minus 2 equals 0. Then list the rational roots. So let's start off by first listing our P, our factors of P, which is the constant term. Here in our polynomial, the constant term would actually be 2. So we want to see what goes into 2. That would be a positive and negative 1, and a positive and negative 2. Now our factors of Q, which is our leading coefficient, here would be a 6. So we want to list the factors of 6. Well, positive and negative 1 goes into 6, positive and negative 2, positive and negative 3, and positive and negative 6. Now to list our rational roots, that's where our P over Q comes into play. So here, this would be positive and negative 1, positive and negative 2, all over positive and negative 1, positive negative 2, positive negative 3, positive negative 6. Now after we do that and take each chunk kind of at a time, we'll eventually get positive and negative 1, a positive and negative 2, positive and negative 1/3, positive negative 1/6, and a positive and negative 2/3. So that's what we're doing when the question asks list the rational roots and how the rational root theorem really works. Now let's take a look at Descartes' rule of signs. Now it states it's about finding the number of positive and negative real roots. So here, the number of positive real roots would actually be the number of sign changes in the polynomial p of x, and the number of negative real roots is actually the number of sign changes in the polynomial p of negative x. So now we want to designate our sign changes by marking either yes if it does change or no if it doesn't. So now taking a look at p of x, going from positive 2 to a positive 3, there's no sign change. A positive 3 to a negative 6, yes. Negative 6 to a positive 6 is yes. A positive 6 to a negative 8 is also another sign change. And a negative 8 to a positive 3 is another one. So here there would be 4, 2, or 0 positive roots. Now, we get the 2 and 0 because Descartes' rule of signs also goes on further to explain that it would decrease by an even number. So since we initially had 4 sign changes, it would either be 4, decreased by another negative number would be 2, or 0. Now let's take a look at our negative roots of our polynomial p of negative x. So here we're plugging in negative x. So we can rewrite this problem initially first by stating a negative x to the fifth would actually be negative 2x to the fifth. Negative x to the fourth is positive, so positive 3x to the fourth. A negative x cubed is negative, but a negative x times a negative 6 would be positive, so it would be positive 6x cubed. A negative x squared is positive, so positive 6x squared. Negative 8 times a negative x is a positive 8x, and then plus 3. So once again, we're going through and we're kind of marking down what our changes of sign are. So here, negative 2 to a positive 3 is yes. Positive 3 to a positive 6 is no. Positive 6 to another positive 6 is no. Positive 6 to a positive 8 once again is no. And finally, a positive 8 to a positive 3 is no. So here there will only be one negative sign change. So now this is just a way for us to kind of see if we have positive and negative real roots and how many different options there would be. It's really a great information gathering technique. Now we're taking a look at what's called the location principle. This location principle states that if f of x represents a continuous function and a and b are two numbers with f of a being negative and f of b positive, then the function has at least one real zero between a and b. Now recall that f of a and f of b, really those are just y values. Now when we graph this f of x equals x squared minus 4x minus 2, and we plug that into our calculators, we'll get a graph that looks something like this. Now we can see where our a and b's are. So here we can see that it's between a negative 1 and 0, which is right here. And we can also see that it falls between a positive 4 and 5. So here we would write our a's and b's as being between negative 1 and 0, also between 4 and 5. So that's kind of how we use our location principle. So that concludes for this lesson. If you guys have any other questions, you can contact me. Otherwise, we'll see you in class tomorrow. Thanks.